I'm Dennis K. McKay, and you're watching the video series I call SurveyorThink. In previous episodes about data standards, I discussed standardizing current and historic survey measurement data. In this episode, I will discuss how surveying operations can make use of this data and how public-facing official version can be easily updated with the results of your survey. This episode is pure proposal. Today's technology is fully developed for everything I'm discussing here, but not all of these ideas have been implemented. So imagine that all land management agencies in the country at the federal level and all 50 states and all 5,000 plus counties and boroughs are publishing their own surveying and parcel standardized geodatabases of their jurisdiction. Portals would have to exist to create the appearance of a centralized database. By accessing a portal, software like your future surveying software could access surveying and parcel data without you having to worry about where the data is kept or which version you should be using. This is the vision of a multi-purpose cadastre. In my enhancement of this vision, you would just navigate to the area of an upcoming job and draw a big shape enclosing the area of your new or potential job. Your software would then just grab the map layers, which are really just published geodatabase table information for all the information that's within that enclosure. And it would populate temporary geodatabase tables with that information, including any survey plat images that happen to be indexed by geography. This information is then placed in a Geopackage file with whatever file name you give it and with a Geopackage file name extension. The Geopackage file is saved to your local device, be it laptop or tablet or smartphone. This offline version of the national published data is under your control and can be edited by only one person at a time, which is you. The geodatabase tables in the Geopackage file can appear as map layers in any GIS software or in future surveying software. What is important is that this wealth of data appears as points and lines on a map that is on your display in the field, and you would be able to interact with the database through the symbols on the map. If you take a GPS reading on a monument, the software can anticipate which monument it could be and will ask if this is a monument shown on the display. If it is not, fine. And if it's a new monument, you would say that. But if you identify your measurement with a monument that is already in the geodatabase on the screen, then things get interesting. Your GPS measurement would be added to the controlled geodatabase table as a new row. It will automatically and without human error contain the coordinates, the datum and projection if any, expected positional reliability, the instrument used, the date and time stamp, who you are based on your login name. It can then readjust the survey measurements in the entire job and make evaluations, updating expected coordinates of nearby points you have yet to visit. It can also flash a warning if it determines if you are at a wrong point or not very harmonious with historic survey measurements, as I have described in an earlier episode. What is important, though, is that it you have just now updated the offline copy of the nationally published cadastre. When field work is done, or you need to share your data for merging with other crews or ask a superior advice, you merely need to send the Geopackage file to someone else for review. If you are convinced that the fieldwork is correct, as a field surveyor, you can automatically update the geometries of your survey into the parcel layer, because these tables are all linked. You'll then have a provisional copy of how the final survey and parcel databases will be published, if it were approved. And now to the review and approval process. You would give the Geopackage file to a reviewer, and the reviewer does not now need to re-enter measurement values by hand. And you could create a paper plat based on the geodatabase tables. And a reviewer can inspect explicit information to show the processes you used and how data is organized and what evidence was used. Once a review and acceptance is finished and a plat is signed, then the paper plat and that same final edit Geopackage file with updated parcel geometries is sent to the authority such as a county surveyor, who reviews and then updates the national data infrastructure. The tables in the Geopackage file have maintained row identifiers that are in the national published tables, so it can be used to automatically update existing records and to append new rows. There are extra considerations if more than one agency is affected by the results of a survey. But there are manageable processes to ensure edge matching along jurisdictional lines. The takeaway from this episode is that robust databases can publish surveying and parcel data in tandem, and their Geopackage files can be used for offline editing environments, where a full copy of the surveying and parcel data for a job area is updated every time a survey measurement is made. This is easily shared information in an understandable format, and by reducing unnecessary work, it is possible to update the nationally published data concurrently with survey plat acceptance, so that the published cadastral data is never obsolete. Thank you for watching. I'm Dennis K. McKay, and this video series has the keyword SurveyorThink.